dividing terms. So we've looked at adding and subtracting like terms, and remember that only happens if they're like terms. We've looked at multiplying terms, doesn't matter if they're like or not. And now we're going to look at dividing terms. I want you to remember always when you see dividing and when you see fractions that they're just another way to write each other. So, if I was going to divide 12 divided by 4, I can probably do that in my head and know that there's 4 3's inside of a 12, so if I divide it up, I'll get 3. But I want you to look at another way of doing this. What if I wrote it out as a fraction, 12 over 4? Well, I can put into numbers exactly what I just said. I know that there are 4 lots of 3 inside of a 12, and I'm dividing it by 4. And what happens is that 4 divided by 4 cancel each other out, and you're left with the 3. And now that you've visualized it that way, it becomes a little bit easier to imagine what's going on with the next problems, where we've got letters now, variables instead of numbers. So if I rewrite 3a divided by a as a fraction, that becomes 3a over a. And when I look at this, on the top and the bottom, I'm going to notice anything that comes in pairs, what we call, they have the same bases, they're both a's, and we're going to cancel them off in pairs. So here, an a divided by a, just like a 4 divided by 4, will cancel off, and I'm left with just the 3. If we take it to a slightly more complicated example, I'll rewrite this as a fraction as well. 24 a to the power of 4 divided by 6 a to the power of 2. Well, to help us visualize this, again, what's going on, it can be helpful to write it out in its full form, kind of like we wrote out 12 as 4 times 3. So one of the first things that we can do is actually ignore the a's completely and just look at the 24 and the 6. You might be able to do it in your head. 24 divided by 6 is going to be 4, but just so you see it, there's 6 lots of 4 inside of a 24, and we still have the 6 on the bottom. And I'm going to expand out that a to the power of 4. So how many a's will there be? Times a, times a, times a, times a. And on the bottom, a squared is going to become times a times a. Now I'm going to look at canceling off the pairs. So for every a on the bottom, I can cancel 1 on the top. For every a on the bottom, I can cancel 1 again on the top. Next, looking at the numbers, the 6 on bottom will cancel the 6 on top. And then looking to see what's left, there's the 4, and how many a's? I've got 2 a's left, so that's a squared. So again, just walking through that, writing it out as a fraction, thinking about what are the factors of 24 and 6 on bottom that we can get to cancel, and then thinking about how many a's would be on top. There would be 4 of them, and 2 on bottom, and 1 for 1, they'll cancel 1 off the bottom, 1 off the top, 1 off the bottom, 1 off the top, and you're left with 4 a to the power of 2. The next example's already been written out as a fraction for us, which is quite useful. So again, if you want to, you might already know in your head, well, 10 divided by 2 is 5, but if you're not sure, you can think about how can I write out a 10 that shows how many 2's are in there. Well, there's 5 lots of 2 in 10. Now I've got the 4 a's and 5 y's on the top. I have a 2, an a, and 3 y's on the bottom. Again, canceling them off 1 for 1. Y, 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 1a and 1a. And the 2 will cancel with the 2, because 10 divided by 2 will leave us with 5. So the final answer here will be 5. And how many a's on top? 1, 2, 3 left. A to the power of 3, and how many y's? 1, 2. Y to the power of 2. So there's your complete answer. So, looking at one more example here, 28 m to the power of 4. and 21 m to the power of 3 times p on the bottom. Okay, so 28 and 21, you might be struggling to think about how to simplify that if you're not sure, but let's think of what things they can both be timesed by. What about factors of 7? 7 times what gives you 28? Well, I know that 7 times 4 will give me 28, and I've got 4 m's on the top. And I also know that 7 times 3 will give me 21, and I've got 3 m's on bottom and a p. Now that I've got it written out like that, I can think that the 7 and the 7 will cancel off, and 1 for 1 I'll cancel off pairs of m's until I run out of pairs. And what's left here? You'll notice this time, unlike the previous problems, there's still stuff left on the bottom as well. So we would leave that on the bottom, and we'll just simplify again. There's a 4 and an m on top, and on the bottom there's a 3 and a p. So we're left with 4m divided by 3p. And I just wanted to show another way to think about this, because some of you might be starting to see a pattern. And it's totally okay to write it out in the completely long version like this every single time and cancel them off one for one if that's helpful for you. So keep doing it if that's what's working for you. But just so you get a chance to see it the other way as well, think of it as subtracting the powers. So I want you to notice real quick. There was a to the 4 and a, if you might remember, to the invisible power of 1. If there's no power there, you can imagine an invisible 1. Well, what's 4 minus 1? It's 3. So 4 on top, take away the 1 on bottom. You're left with 3. And for y? Y to the 5, 3 on bottom, so 5 take away the 3 on bottom. You're left with y over 2. So you can think about it as subtracting the powers, and that can help you do it without having to write them all out. Again here, m to the power of 4 divided by m to the power of 3. Well, 4 minus 3 gives us 1 on top. And the p, there was nothing to cancel, so we'll just leave it as it is. Another example of that really quickly could be something like x to the 7, y to the 9, all over x to the 4, and y to the 2. So if I want to think about that idea, I could visualize writing out all 7 x's and all 9 y's, and all 4 x's and all 2 y's on bottom, and canceling them off one for one. But if you notice, it was also that subtraction idea. So 7 x's on top, take the 4 off the bottom, it's going to be left with x to the power of 3. 9 y's on top, take off the 2 on bottom, you're going to be left with 7 y's, so you'll be left with x to the 3, y to the 7. So that's just another tip for you. Either way to do it's correct, but remember it's not subtracting the numbers. I wouldn't say 28 minus 21, it's only the powers that I deal with in the subtraction. The number you still have to simplify like a normal fraction.